two types of circular motions according to the nature of circular motion. So we have taken two types of circular motion. One is what? Uniform, other one is non-uniform. Uniform and non-uniform according to the omega variable or omega constant, anything. So there we have taken the omega factor to decide circular motion as a uniform circular motion or non-uniform circular motion. Okay, that is one type of separation of circular motion. There is another type of separation of circular motion also according to the nature of circular motion. Okay, na? See here, this guy is going in a circular motion. Even this giant wheel is going in a circular motion, and this is called as conical pendulum. Even that mass, red color one. Okay, so this mass is moving in a circular path. Even here, so there is a nail. One block is connected to a string, and that entire element is on the table. So if you project it, it will go in a circular path. It will rotate in a circular path, something like this, with angular velocity. Even this is also circular path. So all four are circular path, but there is a difference between the left hand side and right hand side. What the difference is? The difference is here the particles or you can say objects or anything, okay, are going in vertically, means their height is changing. Here height of the object is changing. Am I right? Height of the object is changing. Here the man height also changing. See, once man height changes. So this type of circular motion in a vertical plane, I told you, no. So there can be one circular motion something like this. There can be other circular motion something like this. The fan which is rotating in your room is moving in a circular path, but in horizontal plane. The height of the fan, any point on the fan does not change. Height remains same only. Here the particles are moving in vertical circle, or the circular motion in the vertical plane. So that's why it's called as what? Vertical circular motion. In a circular path, height of the particle is not changing. Height of the particle remains same. So this type of circular motion is called as horizontal circular motion. Okay, understood? So some circular motions are horizontal, some circular motions are vertical. So right now we are going to see these two things, but once it comes to advance and beyond the advance, the circular motions can be in a plane also. So first we learn these two parts, then we'll go for that part. Okay, let us see. So we will solve some of the examples of horizontal circular motion now. First we'll complete the horizontal circular motion, then we go to the vertical circular motion, because vertical circular motion is little tougher than horizontal. Okay, because height changes, no, that's why. Here height does not change, so that's why there is no problem. So let us say that a block of mass m is rotating with a string of length L with angular velocity omega on the table. See, this is the nail. String is connected to the nail, one end of the string is connected to the block. Now block has given certain velocity, something like this. Then it will go in a horizontal circular path on the table. I think you are able to imagine, right? Now simple thing, find what is the tension acting in the string. Let us say this is the table and this is the nail. Okay, now I am drawing the other diagram. Same thing only, but in other way I am drawing. So string is connected and this is the block of mass m, let us say, and string length is L. So how this mass is revolving, coming out of the board and going inside the board, coming out and going inside, that is the revolution. Okay, and half of the circular path is out of the board, remaining half of the circular path is inside the board. So we are looking parallel to table. Then what are the forces acting? Forces acting are mg will act on the table, normal action will act on the block by the table, both will cancel out and they are not acting towards the center. Then which one will act towards the center? Tension will act towards the center. So which force will make the block to rotate in circular path? Tension. Tension will make the block to rotate in a circular path, something like this. Okay, na? Then what is the centripetal forces? See, centripetal force is not a separate force. Centripetal force is nothing but some forces will act on the system, components or some forces will give you or act towards the center or away from the center. They will decide what is the centripetal force. That is the meaning. Okay. So the centripetal force is equal to, which is what? T only. T is the only force acting towards the center, because this is the center. T is the force acting towards the center. So centripetal force is equal to m into radius. What is the radius? Is obviously length of the string L, and what is the angular velocity I have given? It is rotating with angular velocity omega, then ml omega square, or else you can write down mv square by L also. L is the radius here. but V is not given, but still you can write down, no problem. Mg and normal reaction does not contribute any force towards the centripetal. Mg and normal reaction are acting perpendicular to the circular path. There is a spring, spring is attached to here, there is a spring and there is a block. The block can move forward and backward. Now this entire system is rotating with, let us say, omega naught. If system is rotating with omega naught, and what is the natural length of the spring is? L naught is natural length or relaxed length of the spring. L naught is relaxed length of the spring. Initially when system is at rest, system is not rotating, then what the length of the spring will be? L naught only. But when it is rotating with angular velocity omega naught, then what will happen? That block will go away, block of mass m go away, and spring will extend by x amount when it is rotating with angular velocity omega naught. Then what is the extension in the spring when system is rotating with angular velocity omega naught? That is the question. Spring is extended by x amount, so then we need to identify that extension value. And this, how does this block will go? The block will go in a circular path something like this. This is the circular path of the block. As system is rotating, the block will go in a circular path like this. Now you got some imagination how it is rotating? Okay. So then what is the force acting towards the center? Who will apply the force towards the center? There is only one thing, that is what Mg will act downward, vertically downward. Normal reaction will act on the rod, vertical upward. Mg and normal reaction will cancel out. They won't contribute anything towards the center. Where is the center? This is the center. Okay, na? As spring is extended by x amount, what is the force acting? Kx will be the spring force, no? Spring is extended, then spring force will try to compress it. Then Kx will act towards the center. Then what is the centripetal force is? Centripetal force is Kx, spring force. So to provide the centripetal force only, spring will extend. You understood? See, we want to move the block in circular path. As block is going in a circular path, there should be some centripetal force. Means some force should act towards the center. Okay, na? So when force will act towards the center, whenever spring is extended. So that's why spring will extend. So that block will go in a circular path. Along with that shaft, you can say. Okay. Now what is the radius of the circular path? What is the radius of the circular path is? L naught is there initially, now it is extended by x amount. Then what is the total distance from the center of the block? What is the distance of the block from the center? So radius is L naught plus x. Circular motion radius is L naught plus x. And rotating with the angular velocity omega. Then what is the centripetal force I can write down? Is equal to Kx. Because Kx is the force acting towards the center. So centripetal force is Kx, which can be written as m into r omega square, mr omega square or mv square by r. Because here linear speed is not given, angular speed is given, so that's why I am using the mr omega square. So Kx is equal to m into, what is the r values? R values, radius value is L naught plus x into omega naught square. Angular velocity is omega naught. But what we need to find out? We need to find out x value. Extension value I want to find out. Extension in the spring when it is going in a circular path. So then this is Kx and this is m L naught omega naught square minus, plus mx omega naught square. Just I separated the terms because x value is required. Take on this side. Kx minus mx omega naught square is equal to m L naught omega naught square. Then x into k minus m omega naught square is equal to m L naught omega naught square. Then what the x value is equal to? M L naught omega naught square by k minus m omega naught square. That is the extension value.